today, there it is. Today is section 8.8, linear and quadratic functions. So we're going to learn about graphing lines. What we want to remember is, first of all, let's remember when we have a linear equation, something like y equals 3x plus 2. Remember that is in standard form, and that standard form, actually it's not standard form, Mr. Mac, that is slope-intercept form. Slope-intercept form. And slope-intercept form is y equals mx plus b. And we need to recognize that these variables are going to be different depending on the equation that we're dealing with. So this is our slope, this is our y-intercept, but something about the y-intercept that we should recognize is that it's always the constant. The constant is going to be the y-intercept. So let's sort of put that here. So the constant will be the y-intercept. So if we had to graph this, let's grab a graph. If we grab that, we plot our slope or our y-intercept first. Y-intercept is 2, 0, 2. Now we use the slope, which is 3, which means we go up 3, right 1, up 3, right 1. And that point is 1, 5. This point is 2, 8. And we notice that we produce, if we continue to use that slope, we produce a constant rate of change. And that would produce that. If I had this equation, y equals 3x squared plus 2, that now is in a different form. This is in y equals ax squared plus bx plus c. So this is considered standard form for quadratic equations when our variables are being squared. So if we graph this, well, we wouldn't be able, there's no shortcut at the moment. That's what we're going to be teaching today. So we would revert back to our H chart and we would plug in some values and find multiple values, multiple points, and then graph it. So the easiest value to always plug in is 0. So when we plug that in, we get 3 times 0 squared plus 2. Now we're always going to do what's being squared before multiplying. So I find a lot of students will do 3 times 0 and then square it, but you have to square 0, then multiply by 3. Orders of operations. Squaring and then multiplying. And you get 2. So here's the interesting thing about this is if we start graphing this, let's actually let's make this a little bit smaller. Let's group it. Let's make it smaller. And let's get our graph again. Can I? No. So let's copy this, copy, paste. So here's our graph. All right, if we plot that point 0, 2, that's the same initial point that we used in this equation. Why? Well, one of the logical things is, remember, this represents the y-intercept. And remember I said the constant is the y-intercept. So they're going to have the same y-intercept. So that is one of the reasons why they ended up the same. But there's still going to be things that are similar and different. Whoops. That's not good. Oh, no, it's not going to let me do it. Please move. Thank you. All right. The next point that we would want to choose is 1. 1's another good x value. That would be the next easiest value to plug in. 1 squared plus 2. Again, we're going to square 1, which is 1, before we multiply by 3. Now 3 times 1 is 3, plus 2 is 5. And our second point is actually the same as before. So this is the point 0.02. This is the 0.15. Do you think that we're going to get the same graph? You think that this graph is going to be the same as that graph? Hopefully you said no. And the reason you said no is because these are two different equations. If they're different equations, then they're going to have different graphs. So this is considerably different. So let's find another point. Let's choose 2 here. Let's plug in 2 for x. We get y equals 3 times 2 squared plus 2. We're going to square 2 first before we multiply by 3. We get 12 plus 2, y equals 14. So my third point would be 214. And now we notice, whoa, that's completely different. That is nowhere near. So 214 is going to be way up here. That's going to be like in this general area. And so that is nothing like this one. So we notice that it doesn't have a constant rate of change. It's increasing exponentially. Why is it increasing exponentially? You guessed it, because of that exponent. So what does that chart look like? Well, we would have to continue to plot more and more lines. We don't know the shape of this. We know it's not a straight line. We know we can't connect the dots. So how does it look? You know, what's going to go on here? How is it going to continue to what's the shape of the graph? Is it going to be fat, flattened, fat like that? Is it going to be skinny? Is it going to be upside down? We don't know. So there needs to be a better way of graphing. So using the plug and plug in the points isn't necessarily the best way to go about it. So we have these things called parabolas. And this exponential or quadratic equations are going to create parabolas. So let's take a look at Desmos. And let's see what happens when we square our variable x. Well, we get this U shape. And this U shape is two things. First of all, it has a bottom point. And that bottom point is called the vertex. And in this case, the vertex is right there. The other thing that it has is an axis of symmetry. You see that this shape is symmetrical, meaning if you folded it, it would fold, the left side would fold on top of the right side. What it also means is the distance, this point is 2 away from the axis of symmetry. And you notice that its mirror point is 2 in the other direction. So it has that type of symmetry, and that goes for all points. Okay, so that's going to be 2.45, 6.03, 2.45, negative 2.45, 603. All right, so let's take a look at what if I put a 10 in front of that. It gets really, really steep. What if I make it a fraction? It gets nice and fat and wide. What if I add 2 to it? Well, it goes up because this is its intercept, y-intercept. So we know that it's going to move here. Well, what if I do this? Here's another fun one. What if I have 2x squared? What if I add a 2x? Ooh, notice the vertex shifted and my y-intercept is 0. Why is my y-intercept 0? Because what's my constant here? It's 0. And notice the axis of symmetry is going to be where the vertex is. And so if it's 1 away or a half away, it's going to be a half away going the other side also. Yeah, those are pretty. Oh, I know what the other one. What if I put a negative in front of the a? What if a is negative? So if a is negative, it flips the parabola and goes down. So those are things that you need to recognize. Now, all right, that's great. Now I know what they look like in the shapes. How can I graph them? So let's take this. We talked about, oh, actually before that, We talked about it being in standard form. So if I give you the equation y equals 2x squared minus 3x plus 7, remember that it's in this template form. So my questions for you would be, what is the a value? What is the b value? And what is the c value for this first equation? So looking at that, a is going to equal 2. B is going to equal -3. And C is going to equal 7. Good. What if I give you this equation? Y equals -4x minus 8. What would my A value be? My A value is -4. What's my B value? There is no, remember B is the coefficient of x. There is no, oh, sorry, let's fix that. Sorry, Mr. Mac made a mistake. My A value, sorry, A coefficient of x squared, coefficient of x squared, coefficient of x squared. My B value is the coefficient of x. There is no x here. So what would my B value be? 0, yes. And then my C value is -8. What if I give you the equation y equals 1/3 x squared let's do plus 4x. Oh, that was weird. Why is that making it? Good. All right. So my A value is going to be 1/3. My B value is going to be 4. And my C value is going to be 0. So really important for us to know how to do that, because when we get this problem, sorry, this is my first problem. Is that my first problem? Yes. That's my first problem. Step 1. So we're going to break this into steps. Step 1 is to find the axis of symmetry. So step 1 is find the axis of symmetry. That's where the graph, and it has the mirroring capability. And there's an equation that you're going to have to use, and it is x equals the opposite of b over 2a. And that's where we're going to use those a, b, and c values. So in this case, this is the opposite of my b value. My b value is -4 over 2 times a. A is 1. So I get 4 over 2, or 2. That is my axis of symmetry, is going to be x equals 2. So let's use the graph. I don't have a graph. Let's go my graph. Let's copy. And let's paste it here. So I know that that symmetrical place is going to be where x is equal to 2. So right along here, it's on the x, that's where x is equal to 2. And what we saw with the parabolas on Desmos is that the vertex will lie on that axis of symmetry. So step 2 is find the vertex. So remember that vertex is going to be the bottom, or the top is going to be somewhere on this axis of symmetry. So I know that this x value represents my x part of my coordinate. So I need to plug it in to this equation. So if I take this equation and I plug it in, so I would get y equals, well, no parentheses needed, 2 squared minus 4 times 2 plus 5. So I'm taking this value, this x value that I calculated, and I'm plugging it in to these x's. All right, and now I'm going to simplify. So we get 2 squared is 4, -4 times 2 is -8, plus 5. 4 minus 8 is -4, plus 5 is 1. So when x is 2, my y value is 1. So I know that this point here is going to be 2, 1. That is the coordinate 2, 1. That is called my vertex. That is going to either be the bottommost part of my parabola or the topmost. We call that min or max. In this case, it's going to be a minimum value. So step 2, we're good. Now, step 3 is plot the y-intercept. Remember, the y-intercept is the constant in the equation. So my y-intercept is going to be 5. So I can plot that point. 1, 2, 3, 4, 5. That's my y-intercept. 0, 5. And so, oh, shucks. Okay, so my y-intercept is equal to 5. Now, because I know this is symmetrical, this line of symmetry is symmetrical, meaning there's a mirror component to this point. So if this point is 2 away from the axis of symmetry, its mirror point is going to be 2 away on the other side. That's the really nice efficiency. So what is that point? That point is 1, 2, 3, 4. 1, 2, 3, 4, 5. That coordinate is 4, 5. That's pretty cool, nice and easy. So that was real easy to find the y-intercept, and it was equally as easy to find the mirror point. So 4, 5. Let's erase that, just we don't need that noise in there. All right, so that's good. So we found, we plotted the y-intercept. That was step 3. Step 4 is plot the mirror point to the y-intercept. And now that's good. We sort of see the shape, but we'd like to have 5 points. So next thing we need to do is we need to find a 4th point. We have 3 points at the moment. Step 5 is find a 4th point. All right, well, let's look here. What x values have we used to this point? We used 0 for x. That's for this point right here. We've used 2 for x, and we've used 4 for x. So what's another x value that we might want to use that would be easy for us to plug in to this equation? Well, I could use 10. Somebody in class used 10, but that's going to give me a really big number. I can use 5, whatever. I can use any number here. But one of the easier numbers is 1. So I'm going to plug in 1 into this equation. So that's how I'm going to find another point. The vertex I plugged in because the vertex is a point, and I did it here. So I'm just going to repeat this process. And in this case, I'm going to use the value of 1. So y equals 2 times 1 squared. What's that equation? Oh, not 2 times. Sorry. It is, sorry, 1 squared minus 4x. Sorry. 1 squared minus 4 times 1 plus 5. All right. So 1 squared is 1. Negative 4 times 1 is negative 4. 1 minus 4 is negative 3 plus 5 is 2. So my other coordinate is 1, 2. And 1, 2, thank you, is my 4th point. So 1, 2 looks like that. And that is, that's right. We always want to label our points. And now we need to find its mirror point. So we look, what is the distance away from the axis of symmetry? It's 1. So we know on its flip side, on its mirror side, it's still going to be 1 away. So that point would be right here. That would be the other point. Technically, it would be our 5th point. What is that coordinate? 1, 2, 3, 2. 3, 2. We're going to label it. And so we found our 4th point. And the final point, well, actually not final, but step 6 is plot the fourth's mirror point. And then step 7 is graph. Connect the dots. So let's take a look here. If we connect the dots, we've got a much better shape. We understand where the bottom of it is. We know where it extends, whether it's skinny or fat, and that's great. So let's take this. I want you to do this one. I want you to, first of all, you want to find the axis of symmetry. Then you want to find the vertex. Then you want to plot the y-intercept. Then you want to graph the y-intercept mirror point. Then you want to find a fourth point. And then you want to find its mirror point. And then I want you to connect those dots. So pause the video. Take a moment to do all that. And then when you're ready, let's go over it and we'll see if your answers fit my answers. When you're ready, push play. So step 1 is axis of symmetry. X equals the opposite of b over 2a. The opposite of b is 4. A, in this case, is 2. So we get negative 4 over 4, which equals negative 1. So I'm going to draw a dotted line where x is negative 1. And I know that my vertex is going to lie somewhere on that line. So step 2 is find the vertex. I'm going to plug my negative 1 into that equation. So y equals 2 times negative 1 quantity squared plus 4 times negative 1 minus 2. So we get y equals 2 times 1. Negative 1 squared is positive 1. Minus 4 minus 2. We get 2 times 1 is 2. 2 minus 4 is negative 2. And y is negative 4. So that point, vertex, would be negative 1. That's what I plugged in from part 1. And then it produced negative 4. So negative 1, 1, 2, 3, 4. Negative 4. Negative 1, negative 4. That's the first thing I do. Second step, next step, is plot the y-intercept. Remember, my y-intercept is going to be my constant. So my y-intercept is going to be negative 2. That's that point. So I get the coordinate of 0, negative 2. Make sure you're labeling. That distance away from the axis of symmetry is 1. So I'm going to just go 1 away from it. And that is negative 2, negative 2. That's the coordinate. So step 3 was y-intercept. 4 is mirror the y-intercept. Step 5 is fourth point. So what x value haven't I used? Well, that's an easy one. I haven't used 1. So let's again plug that in. We're going to do y equals 2 times 1 squared plus 4 times 1 minus 2. All we're doing is plugging that x value back into this starting equation. And that's going to give me a point. So y equals 2 times 1 plus 4 minus 2. That gives me 2 plus 4 minus 2. That gives me 6 minus 2. Y equals 4. My coordinate is 1, 4. So 1 on the x, 1, 2, 3, 4 on the y. Now, it is 2 away from the axis of symmetry, so I will go 2 in the other direction. And that coordinate is 1, 2, negative 3, 4. I have 5 points now, and now I want to connect the dots. Make sure you've labeled your points. The points labeling will be the most important part that will help me determine whether you graphed it correctly. All right, let's take a peek at this one. This one's a doozy. So we're still going to do the same thing. What do we notice different about this? Well, there's a couple things that are different about it. Number one, It doesn't have a b or a c, it just has a single x squared, and my a is negative. Whenever your a is negative, when a is less than 0, you're going to have an upside down parabola. When a is greater than 0, you're going to have a right side. Do you know what happens when a is equal to 0? You're going to have a straight line. Oh, because there won't be an x squared anymore. So step 1, you want the axis of symmetry. X equals the opposite of b over 2a. b is 0. A is -3, so you get 0 over -6. So my axis of symmetry is going to be x equals 0. Where is x equal to 0? Right on the y-axis. So that's my axis of symmetry. Let's find the vertex. So my vertex, I'm going to plug 0 in for x. That's -3 times 0 squared. I'm going to square 0 first, and then I'm going to multiply it by -3. So I plugged in 0 and I got out 0. So my vertex is going to be 0, 0. Okay, that's great. And you'll see the bummer about it, because step 3 is find the y-intercept. Remember, the y-intercept is my constant. So my a value is -3, my b value is 0, and my c value is 0. And this is my y-intercept. So my y-intercept is 0. Oh, what's a bummer is that's also the vertex. So I didn't get another point. And the other bigger bummer is that, it doesn't have a mirror point either, because it's right on the axis of symmetry. So find y-intercept and mirror y-intercept, not applicable. It doesn't work. So we have to go to 5, find a fourth point, which is in this case really second point in this one. All right, so we have to pick an x value. Well, that's all right, I can do that. That's actually not bad. So let's pick x equaling 1. So if we pick x equaling 1, we have -3 times 1 squared. We get y equals -3 times 1. Y equals -3. So my point would be 1, -3. 1, 1, 2, 3. There's my point. Now I can do a mirror point. It's 1 away. So that's going to be -1, -3. That worked. Now we have to find a fourth point. So let's pick another x value. Let's pick fourth point. Let's pick 2. So y equals 3 times 2 squared, -3 times 2 squared. That's -3 times 4, which is -12. So I get the point 2, -12. 2, -12 is going to be 2. -12 is going to be like right there. Its mirror point, it's 2 away from the axis of symmetry, so it'll be 2 away from the other side. And that would get me to -2, -12. Now I have 5 points, and I get to see the shape of my parabola. And we knew it was going to be upside down because my a value was negative. So hopefully that helps. That is a quick summary of graphing parabolas. You do those same points and it'll work every single time.